Unveiling the Truth, a detailed investigation into the OceanGate submarine tragedy. The Titan, an OceanGate submersible, mysteriously vanished on June 18, 2023, in international North Atlantic Ocean waters near Newfoundland, Canada. Stockton Rush, the founder and CEO of OceanGate, was one of 5 persons aboard the submerged vehicle, which was on a tour of the RMS Titanic's wreckage. Since they had enough oxygen for 3 days, the U.S. Coast Guard and its Canadian counterparts initiated a significant search and rescue operation. Parts of the sunken ship surfaced on June 22, revealing the heartbreaking reality. The submarine had collapsed under ocean pressure with no survivors. This incident greatly upset everyone, especially considering the compromised safety measures. Today, we will delve into the details to understand what happened. OceanGate History. A brief overview. Let's start with what we know about OceanGate Incorporation, the company that ran the Titan submarine. The Everett, Washington-based company is privately owned and sells basic submersibles for research and exploration and the tourism industry. In 2009, Guillermo Solon and Stockton Rush founded the business. Rush, aspiring to be an astronaut, got his commercial pilot's license but was unable to fulfill his dream of becoming a military pilot due to his weak eyesight. He later relocated to Seattle from San Francisco and began working at McDonnell Douglas as a flight test engineer for the F-15 Eagle. Rush's passion for space travel changed to one of underwater exploration as he sought an exploratory experience like Captain Kirk's aboard the Enterprise. Rush married Wendy Rush, whose ancestors Isidore and Ida Strauss sadly perished in the Titanic disaster. We arrive at the current story due to this specific relationship to the Titanic. The unlucky incident happened during a deep-sea tourism mission intended to investigate the Titanic's remains, which sank in the North Atlantic in 1912. It's important to understand the challenges of deep-sea exploration before diving into the intricacies of this catastrophe. The challenges of deep-sea exploration. Deep-sea exploration is superior to aviation and space travel since they can defy gravity and move through the air. But due to the tremendous pressure they must withstand, deep-sea vehicles provide an even bigger engineering challenge. The air column extends to the farthest regions of space, where the air pressure is felt to be 14.7 pounds per square inch. The pressure rises by 1 atmosphere, 14.7 psi, for every 10 meters, 32.8 feet, of depth as water is denser than air. The Titanic rests over 12,500 feet deep in the sea, with its broken bow and stern separated by over 2,600 feet among the debris. This underwater wreckage, which has been there for over a century, can be found 400 miles off the coast of Newfoundland, Canada. To grasp the immense depth, picture yourself lying down with a small board on your chest. At 100 meters deep, similar to the length of a soccer field, the pressure is 10 atmospheres or 145 psi. The board would bear a force equivalent to 20,880 pounds, similar to 4.7 Tesla Model Ys. At 381 meters, 1,250 feet, akin to the Empire State Building's height, the pressure skyrockets to 37.4 atmospheres, and the weight on the board reaches a staggering 80,000 pounds. The U.S. Navy's C-class submarine, at its maximum dive depth of 490 meters, faces 48.5 atmospheres, with the board burdened by 94,800 pounds. Finally, at 828 meters, the height of the Burj Khalifa, the pressure soars to 82 atmospheres, and the weight on the board becomes an astonishing 173,520 pounds. At a depth of 3,800 meters and 376 atmospheres of pressure, the Titanic wreckage is submerged. Nearly 797,000 pounds would be supported by the board on your chest. While James Cameron and the Deep Sea Challenger broke the record for deepest dive in 2012, the OceanGate Titan can only descend to about 4,000 meters. The Deep Sea Challenger descended to the lowest point on Earth, at 11,000 meters, 36,000 feet, the Mariana Trench's deepest point. The board on your chest would be weighed 2.3 million pounds at this enormous pressure of 1,090 atmospheres. Comparatively, the pressure difference inside and outside an airplane at a cruising altitude of 36,000 feet is just between 7 and 9 psi. This puts into perspective why more people have ventured into space than the deepest parts of our oceans. Now, let's discuss the numerous warning signs that surrounded OceanGate. Warning signs surrounding OceanGate. The name OceanGate hints at tragedy from the beginning. To prevent unauthorized access, the Titan's hatch was designed to be externally locked with 17 to 18 bolts. While protecting water seals in deep-sea vessels is a legitimate design consideration, it also emphasizes the critical need for safety precautions and backup systems. One such safety measure could be an explosive cord that, in an emergency, could be deployed to forcefully open the hatch if the craft resurfaces but is not seen. The Titan lacked GPS or navigational instruments, including a locator beacon. Unlike most submarines, it relied solely on data from the surface support vessel for navigation instead of employing GPS, dead reckoning, gyro compass, speed measurements, and ocean current estimates. In 2019, OceanGate's blog post defended why the Titan lacked maritime certification, raising concerns. They argued that most accidents stem from operator error, not mechanical failure, suggesting that certification focuses solely on the vessel's physical state, disregarding the company's commitment to operational safety. However, this explanation appeared unconvincing to many. In 2022, journalist David Pogue joined the Titan to explore the Titanic. During the trip, the surface support vessel lost track of the Titan for 4 to 5 hours. The need for a locator beacon was discussed, as they had no idea where the sub was. They could still exchange brief text messages with the sub, but its location remained unknown. To maintain secrecy, they disabled the ship's internet to prevent passengers from tweeting about the situation. Furthermore, the Titan was controlled using a video game controller, which seemed inappropriate given the seriousness of the operation. Military-grade products undergo rigorous testing for safe operation. For instance, Apple's Vision Pro headset, priced at $3,500, is considered inexpensive compared to the stringent standards of military-grade equipment. The history of the Titan submersible. The helmet made specifically for the F-35 combat plane costs $400,000. Its high cost is due to its limited production and rigorous testing. Extensive vibration testing on the helmet ensures the welds are strong. At high altitudes of 40 to 50,000 feet, it is also tested for radium resistance, and its high reliability is assured. OceanGate initially bought Antipodes in 2012 and used it as a Titan test site. They received priceless instruction and information from it. They received assistance from the University of Washington's Applied Physics Laboratory when developing their future project, Cyclops 1. Although it was far from the Titanic's depths and had a maximum depth of only 500 meters, it was a step towards their ultimate goal. Early versions of the submersible had a carbon fiber hull and were designed to dive vertically, with swivel chairs to keep occupants upright. On the first design analysis, Boeing allegedly worked with OceanGate and the University of Washington. But more study of this component of the story is necessary. The final iteration of OceanGate's submersible, the Titan, had a remarkable depth capability of 4,000 meters. One standout feature was its hull, constructed using a combination of carbon fiber and titanium, sophisticated materials and engineering. Carbon fiber remains relatively uncommon compared to traditional materials like high-strength steel and aluminum. It is rarely found in most cars, except for very high-end supercars. Similarly, carbon fiber has only recently been incorporated into the aviation industry, as seen in the Boeing Dreamliner, with aluminum and titanium being the preferred choices for their well-known properties. Working with carbon fiber poses a distinct challenge due to limited knowledge and the need for precise manufacturing. Concerns and red flags raised. Spencer Composites built hulls for OceanGate and Steve Fawcett's Deep Flight Challenger. Virgin Oceanic acquired the Challenger, but its single dive design limited its use. The Challenger's strength diminished with each dive, peaking on the first. It was originally intended for a record-setting dive and Smithsonian exhibition. The concept of an operational lifetime is crucial and relevant to the Titan situation. OceanGate's website was deactivated on June 22. The University of Washington's Applied Physics Laboratory denied involvement in the Titan's design, engineering, or testing. Boeing and NASA also confirmed no partnership or contribution to the Titan project. These revelations cast doubt on OceanGate's claimed partnerships and affiliations, suggesting a desire to enhance credibility through famous associations. David Lockridge's Quality Control Report. In January 2018, David Lockridge, Director of Marine Operations at OceanGate, revealed the absence of a non-destructive investigation, NDI, for the carbon fiber hull, which could compromise its strength. The vessel's acrylic window was only rated for 1,300 meters, not 4,000 meters. Lockridge was dismissed after persistently expressing his concerns and demanding a hull scan. In June, OceanGate sued Lockridge for improper disclosure and fabrication of dismissal reasons. The case was settled in November 2018 under confidential conditions, leaving us with little information. Communication problems and incidents. During a dive beyond 10,000 feet on December 10, 2018, Stockton Rush encountered unexpected positive buoyancy, requiring thrusters to counteract it. This interfered with communication, causing a 1-hour loss of contact. Rush declared himself the second person to solo dive to 13,000 feet after James Cameron. In January 2020, the Titan's hull showed fatigue, lowering its safe depth to 3,000 meters. It was repaired and re-rated for dives up to 4,000 meters. The importance of understanding risks in exploration. This video was created because we are entering a new era of exotic tourism and exploration. From space travel to deep-sea diving, we stand at the threshold of a wave of new explorations. Wealthier individuals, like those involved in this incident, are driven by the allure of the next big thing. However, it's important to understand the risks as we venture into uncharted territories. Compared to commercial aviation with stringent regulatory oversight, this new domain lacks such control. International waters, where these activities often take place, have limited regulations. While the parent vessel was registered, much of what happens in open waters remain largely unregulated. Operational lifespan and material considerations. Aircraft benefit from rigorous testing and safety measures, but exploration in this new era lacks the same level of scrutiny. Implosions at great depths can be instantly fatal due to extreme pressure. The Titan's operational lifetime was uncertain due to a lack of non-destructive tests on carbon fiber. New frontiers like space tourism lack established guidelines. Vessels built for deep-sea pressures face unknown factors and may experience deformation over time. They should have a limited lifespan. The cost of deep-sea exploration. Ticket prices, originally starting at $125,000 and later doubling, should have been much higher, possibly around $1 million. This would have allowed for regular vessel replacements and thorough testing. However, cost-cutting measures were likely taken to make tickets affordable, resulting in insufficient risk understanding. Lessons learned and the path forward. It's tragic, but there was no rescue or lesson learned without loss of life. Engineers must learn from mistakes and prioritize safety awareness. Future deep-sea exploration will likely require more costly and improved methodologies.